Hi everyone. So today we will be starting with our first question from two pointer. In the previous video, we discussed about the basics of two pointer, where it is used, and yeah. So today we will start with the first question in the list. So from this leetcode pattern website, we are solving these questions. So first question is merge to sorted list. So let's see. So let's try to understand the problem statement first. So we are given two lists which are initially in the sorted order, and let me start this. So initially we are given two lists as input, list 1 and list 2, which are in sorted order, and what we have to do is we have to merge both of these linked lists, and the resultant list should be in the sorted order as well. So this is the problem statement. Like here we have 1 to 4 and 1 3 4, then we merge it somehow, and then we get a sorted list at the end, right? And one more thing, which is an important note here, that the list should be made by splicing together the nodes of first two lists. So what this means is that we don't want to create a new list and then add copy these elements in that, the data in that. We have to modify the existing list, the pointers of the existing list, such that it becomes sorted. So right now let's talk about the intuition, so how we can get to a solution. Let's do some drawing for that. So we are given these two lists, and this is list 1. Let me just change the color. So this is the list 1 and this is list 2, and we want to get merge these and sort. So one very simple approach is that we directly just merge them. What I meant by that is we go to the tail of the first list or the second list. So let's say we come here somehow, and what we do is we append all the elements of list 2 here. So what we can do is we can effectively create this list. So 1 3 and 4, right? So what we are doing here is we are just making the next pointer of this point to head of the list 2, right? And then what we do, we perform a sort operation on that list. So let's see what will be the time complexity of that. So if we have to merge, that will be order n plus m. So given that size of this list is n and size of this list is m, so this is for merging, and then we will sort it. So for sorting, again we will get n plus m will be the size of the resultant list, and then we will sort it, so it will be log n plus m. So this will be the time complexity of this naive solution. And yeah, so now let us try to improve this solution, right? So yes, if I remove all of this, and yeah, so what ideally what we are doing is we are just changing the pointer. So let's keep a pointer right here that is pointing to the first list, and keep a pointer that is pointing to the head of the second list, right? So what we want to do is we want to change the link. So how we can make that decision? So if we think a little, what we have to do, let's say for explaining, I just move this to right here, and it is pointing here. So we want to modify these pointers, and if I just change this as well for just a second, and let's say this is the list that we have. Now we want to make a decision, which pointers should we change. So it makes sense that we go with the pointer that is pointing to the lesser value. So here lesser value will be L2. So we change this link. So effectively what we do is we remove the next of this, we attach this one, list 1 to list 1. So this is the current state, and what we do is we move the second pointer ahead. So what we can do is we can first save that next link which we had right here, and then move it, right? So that we will see in code how we can do it. So we have moved L2 here. Now let's say which one is the lesser value. So now L1 is pointing to the lesser value. So we want to change its next pointer. So it should be pointing right here to L2. And we, like I said, we stored this next link before destroying it. So we just move L2 right here and L1 right here, and L2 is still here. So now the lesser value is L2. So we change the next link of that as well. So next will be pointing to this one, and L2 will move to this one right here, right? And now which one is the lesser value? So let's say both of them are equal. So what we do is we change any one of them. So let's say I'm changing L1. So L1 next will be pointing to L2, and now L1 will be moving to null, right? So L2 is just pointing to nothing here, right? We can call it null. Now we can see our list is in the sorted order. If I flatten this one, so it will be 1, 1, then 2, 3, 4, and 4, right? So this is the basic idea of solving this problem. So now let's look at the solution. So we have these two lists, and what we are keeping is we are keeping an extra head. So this will be clear why we are keeping an extra head. And list 1 is pointing to head of first list, and list 2 is pointing to the head of second list. Right, so we want to decide where the head should be pointing first. So because at the end it is given that we have to return the head of the merged linked list. So we want some way of keeping the head, right? So later on we can return it. Yeah, and let's start. Okay, so we are deciding initially head should point to which value. So for that it makes sense that head initially points to the lesser value out of list 1 and list 2. So here they both are same, so we can see here list 1 is 1 and list 2 is also 1, so they are equal. We can point it to any one of them, right? So we move the list 1 to its next, and we move the head that will point to list 1 right here. Yes, so let's start. Now we want another pointer for current. So this current will be doing all the updation part. We will see how it will update the links, right? And so initially the current will point to the head, and then we decide the link to change. So now we have to make a decision which link we want to change. As we have seen in the intuition part, we were changing the links. So right, so list 1 is currently pointing to 2 right here, and list 2 is currently pointing to 1 right here. So here list 2 is less than list 1. So what it makes sense that we change the link such that we remove this link right here for current, and then what we do, so we have removed the link. So now we want to establish a link. So we will establish a link via current. So we say current next will be pointing to list 2. So we have established this link right here. Now again we will move the list 2 pointer. Since its work is done, we will move it ahead, and we will move the current as well. So current will start pointing to its next, right? So next we again make a decision which link to change. So right now list 1 is pointing here to 2, and list 3 and list 2 is pointing to 3 here. So in this case list 1 is less than list 2. So what it makes sense, we delete this link, right? And we make this new link here. And now since we are pointing to this one, we don't need this list 1. So we move the list 1 ahead to its next, and we move current to its next right here, right? Again we have to make a decision. So list 1 is pointing to 4 here, and list 2 is pointing to 3 here. So in this case list 2 is less than list 1. So what we want to do is we want to change this link. We cut it off, and we make current next to be list 2. And now similarly, since this work is done, we move list 2 next to this 4 here, and we move current to current next, right? Again another decision. So since here this is also 4 and this one is 4 as well, we want to change. So this current next we will change. We will remove this link right here. We will make a newer link to list 1, and list 1 will move to next, and the current will move to current next. So now list 1 is pointing to null. So this is the exit condition of our whatever loop we are using. And then at the end I have flattened this list, and the head was pointing right here through the entire iteration. So we return the head, and yeah, that will be our solution. So let's start looking at the code. So we can start coding this solution. So I'll open up my text editor. So we are given a function as, so I've copied this one from right here from leetcode, this function. So now we will start implementing this. So there are some base cases. Let's say if the list one is empty or either the list two is empty. So let's handle that first. So if list one is empty, right, so we return simply list two. And if list two is empty, then we return list one. Now why this makes sense? So we can see right here, we move a bit down. So let's say our first list is 1, 2, and 3, and the next one is like nothing, null, right? So this is list 1, this is list 2. So it makes sense if L2 is null, we return the L1 because that will be the sorted list at the end, right? So these are the base cases. Now we want to decide head as we saw in the solution. So we can make a new head pointer right here. Head initially it will be null. Then we make a decision that if list one, let's say, I think it is called data in the actual structure or value. Okay, so it is value, right? So list one value, if it is less than or equal to list two value, right? That means we want head to be pointing to list one, and the list one should be pointing to list one next, right? Otherwise, if list 2 value is empty, so we want head to be pointing to list 2, list 2 should be pointing to list 2 next, right? That makes sense. So now we will have the current pointer. So let's create a new current pointer which will be pointing to head initially. Now we want to decide upon a condition, which was that neither of list 1 and list 2. So the exit condition is that either one of them becomes null. So we will exit out of this while loop. Now what we want to do, the first step is to see which value is less. So if list 1 value is less than or equal to list 2 value, we will do something here, or otherwise we will do something here, right? And there is, so in this condition what we were doing is we were saying that current next should be equal to list 1, right, since that is the lesser value out of both, and we want to move the list 1 to list 1 next, right? And then here current next will be pointing to the lesser value, which is list 2, and list 2 will be moving to list 2 next, right? And there was one common movement of the current pointer, which was current should be moving to current next every time, right? So we are done with this loop. So updation of links, I think, yeah. And now since let's go back to this one, right? So at the end we can see we are missing out this link here. So this current should be pointing to something at the end. So current next should be pointing to this one. So we want to make that last link. So for that, what we will do, we will say current next will be equal to either list 1. So if list 1 is equal to null, then we say we will be pointing it to list 2. Otherwise, we will be pointing it to list 1. Right. So since in this case, list 1 is empty, what we will do, current next will be pointing to list 2. So this link will be created, right? Yeah, and at last we will just return the head. And I think this should be working now. Let's just copy it and try submitting it here. And just remove this function, copy ours. Let's see if it runs or are there any errors. So it is running on the test case. Let us try to submit this. Yeah, so it is running fine. There is this time limit is 9.49. I guess we did something different from our previous solution. So let me try to submit it once again. Maybe there is some issue. Right, so it is changing again. Previously it was 4, like it was basically the same solution at that time as well. So yeah, so we get the basic idea. So that was it for this video, and if you like the video, do hit the like button and subscribe to the channel. Thank you.